Hello, my name is Arthur, and I'm going to present our project called Blockchain for Additive Manufacturing Traceability. So additive manufacturing is a broad topic which consists of various technologies. Today, there is a major trend going to printing metal parts. So we at Alchemat have developed a laser powder bed fusion machine here in Brazil, and we are printing metal parts from powder. So there are lots of reasons to why we are investigating how to track it with blockchains, because it's a complex process consisting from 3D modeling to quality check. So several companies participate in this workflow. And as such, we are looking to store information regarding like part design, manufacturing planning, and post-processing of the part. So the part is designed, then it is manufactured, and then usually it gets some post-processing like stress reliefs, heat treatment. There is also support removal, surface finishing, and then it goes to quality check that must be usually non-destructive because we work with small batch production. So if we build one workpiece, we are not going to destroy it on a quality check test. But so this is the context. This is an industry that is that have applications on aerospatial and also medical usage. Like so, you need to guarantee part quality in one single build print. So it is very important that we trace every company participating in this process, because you need to have all data stored to trace it back. Then a blockchain is a good solution for that. And so the process itself for printing the parts has lots of variables. So like particle size, shape, and distribution. So we need to have flowability, and that depends heavily on the shape of the particles. Like here we have stainless steel 316L. On the left, it is gas atomized, so it has a spherical shape, and so it flows better. And then we have also water atomized powder, which does not flow very well. But that's some kind of information that would imply directly on the quality of the part, so it must be stored and then traced back. So just to explain a little better, but the shape of the particle permits flowability of the powder through a nozzle, for example. So it is important to densify the printed parts. Then we have also another set of parameters like layer height, head spacing, filling, and layer rotation. This is regarding the trajectories and also the style of our laser. So here you can see the spot size of the laser, the distance between tracks, the layer height, the temperature of the powder. So lots of those variables compose what we call volumetric energy density. So all of this is going to be we set to be concatenated, and then a hash is going to be generated from this data to protect the data, but also to store the hash on the blockchain. And so you guarantee that the information stored by the company is related to the hash stored on the blockchain. So here is just an example of printing a part. This is a 2D scanning that is going to construct this 3D part. And then for post-processing, we could have tumbling to polish the parts with vibration and hard particles, and also blasting. So blasting blasts hard particles into the surface of the part to give it better finishing. So, as already mentioned, also heat treatments and stress relief, and also hot isostatic pressing to eliminate all porosity on critical parts, like for implants on people. So to finish, we also have quality check that would go through like 3D scanning and tomography. So those are processes that do not destroy the part, and you can compare it to the 3D model and also have a blueprint of the part. So we focused our team on developing a smart contract to store data related to quality check, post processing, and manufacturing of the parts. So my colleagues will show you the smart contract and also an application interacting with the smart contract.
Hi, my name is Matheus, and I will briefly explain how we translated the domain problem into a smart contract. So first, with the structures that we have defined, we defined just post-processing and quality check procedures, both of which have an address of the company responsible for the procedure, a string describing the process, and another string describing the process parameters, but it's actually a hash to the process parameters so that we don't accidentally reveal industrial secrets, and both of which also have a date, as in a Unix epoch time of when the procedure was made. And as for the part, we just defined it as having an unique ID, which is we'll show how that's defined later. We also have addresses for the current owner as in ownership, for the first owner, and the company that manufactured and designed the part. We also have a string defining the initial process of how it was developed, as well as the parameters. Again, a hash of the description. And then inside the part, we have an array for post-processing and for quality check procedures, as well as a Unix epoch time for the date of when it was manufactured. So the parts are just stored as in mapping, as an array, so that we map in integer to the part itself. And then we have a universal part ID counter, which just increments every time we insert a new part. Then we have the function to modify ownership, which requires a part ID as well as the owner or the new owner. And the function requires that the sender of the message is either the contract or the current owner of the part, so that we protect who can actually edit this information. Then we have a create part function that just you pass the parameters necessary to create the part, and then it immediately stores into the parts array and increments the part ID counter. And then for adding post-processing and quality check, both functions are almost identical. You just pass through the part ID of the part that you want to add post-processing or a quality check procedure to, and then the parameters necessary to describe the post-processing or quality check procedures, and that will just push the information into the part, as well as modify the ownership of that part so that it can be traced uh, who the part is in possession of immediately. And so it also a getter function for both of them that just returns the part, the array contained within the part, as well as a getter for the part itself so that you can check all of the information. With that, Gabriel will actually describe the application that we have developed for this project.
Hi, my name is Gabriel, and I will be presenting the application that we developed. So, This flowchart represents the process of part creation for additive manufacturing. At the start, the part is created and the part data is stored in the blockchain. After that, if there's any post-processing, the post-processing data is stored. The same thing happens with quality checks that guarantee the part quality. So we can add how many quality checks and how many post-processing information we want. And after quality checking, the ownership is changed. And if the manufacturing is over, the cycle is considered as finished. This class diagram represents how the data is stored inside our contract. At the body of the contract, we store the list of parts and an index that accumulate every time that a new part is added. And related to it, inside each part structure, we have the ID, the ownership, who manufactured the part, who designed the part, all the post-processing information, all the quality check information, and manufacturing date. And this and for like each post-processing and quality check information that are related to that part, we store this information inside the blockchain as well. So let's go to the application. We develop 8 functionalities, 8 methods. We are adding parts into the blockchain, retrieving parts from the blockchain, changing ownership of a part, adding post-processing information, retrieve post-processing information, adding quality check information, and retrieving quality check information. We are also getting the ownership history, but the responsibility to get the ownership history is not related to the contract, but related to our application. So our application is responsible to return the ownership history ordered by date. So here's a table that shows the amount of gas that each one of our methods would spend. So we have the information here of the amount of gas, and if we connect to external APIs that calculate this amount of gas inside a production network, we could get the information of how much would we spend executing this method of our contract, and have the information of how much this contract would cost to be used in a real blockchain. So let me execute here the project. So we have here a list of wallets. We can, like I said, we can add parts, retrieve the part information from the blockchain. We can change the part owner, add how many quality checks and how many post-processing information we want. So if I get the part information again. Here's the list of processing and the list of quality checks, the information of quality checks and the information of post-processing, and we can get the part history. So this is a list of ordered by the oldest data to the newer data, history of ownership of the part. So basically, this is our application. Thank you for your time.